So what we're going to do in this chapter is think about situations where we don't have all of the information about the population, but we still want to use sampling distributions to come up with some estimates about the population. So for example, we've been working with sampling distributions already, and in these cases, they pretty much fall into a couple of different types. And so on the one hand, we've been dealing with situations where we know exactly what the population looks like. So for example, last notes, we had a gamma distribution where we were thinking about how long is it going to take someone to catch 5 fish, and in that case, we knew exactly what the population looked like, and then we were able to come up with some estimate about what some reasonable sample statistics might be. In the case of doing hypothesis tests in chapter 3, in those cases, we make an assumption about the population. So, for example, when we were dealing with the flight data from airlines, although we didn't have all of the data from those airlines, we would make a claim like there's no difference between United and American airline flight delays. And then we set up a simulation using a permutation test to look at what are reasonable sample statistics. So in that case, we use some simulations to construct a sampling distribution based on some claim about a population. So the question might be, well, what happens if I don't have any claim in mind about a population, but I want to come up with an estimate, like what is the mean delay time for United flights? So there's no claim about that value. I don't have access, so I don't know what the population mean and standard deviation are. So how can I create a sampling distribution and then answer some questions based on that sampling distribution? So that's going to be the goal of chapter 5, is to think about how from one sample we can generate an estimate for a sampling distribution. Okay, so here's the first example that we'll think about to get the ball rolling on this. So we're going to use a data set called NC Births 2004. So this is from our textbook. So if you load the library resample data, that data set will be in there. And so that data set contains a random sample of 1,009 newborn babies in North Carolina in 2004. And if you look at the data set, you'll see there's a number of variables in there, such as the mother's age, whether the mother used tobacco or not, what gender was assigned to the baby at birth, weight, and the gestation period, how long was the mother pregnant when the baby was born. So we'll take a look at this data set in some other cases moving forward. And if we say wanted to come up with an estimate, which is what this question is saying, what is a good estimate for the mean weight of all babies born in North Carolina in 2004? Well, being that we have this data set of 1,009 babies, this is not all of the births, so this is a random sample of births, then we could use our, for example, we can load up the library resample data and then calculate the mean of the variable weight inside of this data set. And what we see here is that the mean weight of newborns was 3,448.26. And here what we should note is that we're measuring this in grams. So this would be a good starting point for our guess, right? If someone asked you, here's a data set of 1,009 babies, we want to come up with an estimate for what the mean weight of all babies would be, this would be probably your first starting point was, let me calculate the mean of my sample. And a couple of points here, and that is, first of all, this sample was random. And it's pretty large. There's over 1,000 values in here. So it should be a really good representation of the population. It is not going to be perfect because it doesn't contain everybody from the population, but this should be a reasonably good estimate. The question is, how reasonable, how much error should we build into that estimate? So it's not going to be exactly 3,448. What would be a reasonable amount of error that we can attach to that estimate? Okay, so let's come up with a game plan for how we can estimate sampling distribution. So what we're going to do is we're going to start with one single sample. For example, 1,009 values corresponding to babies in North Carolina. So we just have one sample of size n. So from that sample, we're going to construct a new sample by picking n values, the same number of values from the original sample with replacement, obviously. So if we picked n values without replacement, then we would definitely get back the same exact n values. So I'm going to take my sample, I'm going to pick a value, then I'm going to put that value back in, I'm going to pick a second value, I'm going to put that value back in, pick a third value, put it back in, and we're going to repeat this n times, right? So I wind up with what we're going to call a bootstrap sample that has n values in it. Then we take that bootstrap sample and we calculate some statistic. For example, a mean of that bootstrap sample, or maybe a proportion or a variance. And then we go back and generate a new bootstrap sample, calculate the statistic for that new bootstrap sample, and we keep going on and on and on and on again. And then we can look at the distribution of all of our bootstrap statistics. So it's very similar to what we do with the sampling distribution. Instead of picking a bunch of random samples from the population, we're now picking a bunch of bootstrap resamples from our original sample. So let's take a look at an example here to get a sense of what bootstrap samples might look like before we jump back into the example with the births. So let's say, for example, our original sample, instead of 1,009 values, let's just start with a more manageable amount of values. So we're going to start with, let's say our original sample had 4 values. And let's think about each of these possible samples, each of these 5 samples here, and see which of them could be a possible bootstrap resample and which ones not. And you might want to just hit pause here and try and answer this question for yourself, but I'll go through it. So in the first one, we've got these 4 values. The value 3,800 was picked. It gets put back in. We pick a second value, 3,065. We put it back in. And then we pick a third value, 4,010. And then we stopped. And so here the problem is our original sample had 4 values. This bootstrap resample only has 3. So that's a no for this one. Our sample should have the same number of values as our original sample. So 1 only has 3 values, that's no good. And for the same reason, the sample in 3 would be no good because that one has too many values. We should only have 4, that one has 5 values. So 3 and 4 are out because one definite requirement is each bootstrap sample should have the same number of values in it. Okay, so now let's look at 2, 3, and 5. Since they all satisfy that criteria, they all have 4 values in it. So in 2, we've got the value 3,800 4 different times. Could that be a possible bootstrap resample? Absolutely. So that would be a yes for 2. Because we're picking with replacement. So I could pick 3,800 first, I put it back in, I could pick it again, put it back in, and I could actually pick the same value 4 times. So that's definitely a possibility. Looking at the third one, we pick a 3,800 first, we put it back in, then we pick 3,065. That's a value, we put it back in, 2,950, and then 4,100. This is actually the same exact sample that we started with. And so it is possible that we could pick a Bootstrap resample and get the original sample back. We've got 4 values. Each of those 4 values was in the original sample, so that's possible. And looking at the last one, we've got 4 values. I could pick 3,800. I could pick 3,065. I could pick 2,950. 3,450, where did that come from? So there's no way that I could have picked it from these values up here. That wasn't one of the original values. That's not in there. So this last one would be a no. So hopefully that gives you some sense about what the Bootstrap resampling process involves. And as we're going to set up simulations to create these Bootstrap resamples, these Bootstrap distributions, it might be good to just think about, well, how many possible Bootstrap resamples can there be? And so if we return to the North Carolina birth weight example, N was 1,009 because we had 1,009 observations. And so for the first value that we pick, we have 1,009 possibilities. Then we put that value back in, and we pick another value. And so pick number 2 has 1,009 possibilities as well. And we would keep doing it. And each time we pick a value for our Bootstrap sample, we've got 1,009 possibilities. So basically, what we're getting is a total of 1,009 raised to the power of 1,009. Go ahead, try calculating that in R and see what you get. That's really, really large, and in fact, I think you might blow up R if you try doing that. If you don't trust me, give it a shot. But the point here is that there are tons of Bootstrap resamples that we can generate.